All right, this is Honors Algebra 2 Pre-Calculus. We're doing section 9.1 in Pre-Calc, which is sequences and series. So in example 3, we're given sequences, 3 of them. We're going to do each one separately. And in each case, we're going to try to write an explicit formula for the nth term, right? So the thing to remember here is that this first term in all of these sequences is when n is 1, right? So as we're establishing a pattern and trying to figure out what our pattern is going to look like in each sequence, some of them are going to be pretty obvious, and some of them are going to be slightly more difficult. So when you look at this, this is about pattern recognition, right? You want to start by looking at hey, n is 1, is there a pattern that happens after this, right? So for instance, let's look at part A. In part A, we see that the pattern seems to be 2, 4, 6, 8. If I were to find the next one, I'm guessing it would be a 10, right? Like I see a pattern happening. And it seems to me that there are 2 ways to get a 2 from n equals 1. I could either be adding 1, like n plus 1, which would give me a 2, but that falls apart really quickly because when n is 2, if I did n plus 1, I'd get a 3, and that's not right, right? Or it could be n times 2, right? So if n is 1 and I double it, I get a 2. If n is 2 and I double it, I get a 4. If n is 3 and I double it, I get a 6. And if n is 4 and I double it, I get an 8. So sure enough, 2n seems to be the pattern I want. So what you're going to do is you're essentially going to make a hypothesis, like, oh, hey, it looks like if I double that first term, right, if I double n, I get the first term. If I double the next n, do I get the next term, right? So what you're going to be doing is kind of guessing and checking and looking for a pattern. So let's talk about B and some of the things that we see. The first thing I want to notice about B is that you'll see that it has this alternating sign. Every other term comes out negative, right? So when you see an alternating sign, what that means is that your term either has a negative 1 to the n, or it has a negative 1 to an n plus 1. The reason it's got that negative 1 to a power is that's what's changing the sign every time. That negative 1 to a power means that if a negative 1 is to an odd power, you get a negative, but a negative 1 to an even power gives you a positive. And since it's a 1, no power of it actually changes the numerical quantity. It only changes the sign, right? So which of these I pick is largely going to depend based on what happens when n is 1. Notice that when n is 1, I want my number to come out negative. Well, because when n is 1, I want my number to come out negative, I want a negative 1 to the 1 as opposed to a negative 1 to the 2, which is what happens if I pick n plus 1. So I now know part of my pattern. So my hypothesis is that part of my pattern is that a sub n is going to be a negative 1 to the n. Again, that's the part that's alternating, right? So that takes care of the sign, and you can check if that hypothesis works. If n is 1, you'd get a minus, but if n were 2, I should get a plus sign, because it would be negative 1 to the second. If n is 3, I should get a negative again. If n is 4, I should get a positive again, because it would be an even power on a negative. And if n is 5, I should get a negative again. Cool. Now let's look at the next part of this pattern. The other thing you're probably noticing is that these are numbers that we're familiar with. 1, 4, 9, 16, and 25. If I asked you what do these numbers have in common, I think most of us would say, oh, those are perfect squares. So my next hypothesis is that the term itself, ignoring the sign, that the actual number part is just n squared. Because if n is 1, 1 squared is 1. If n is 2, I get 4 when I square it. If n is 3, I get 9. So my hypothesis is that the second part of this term is a negative 1, so negative 1 to the n, and the second part is an n squared. So then we just check, right? So I look and I say, okay, let's see if this works when I plug in n as 1, right? If I plug in n as 1, I get a negative 1 to the first times a 1. Well, that comes out as a negative 1. If I plug in a 2, I get a negative 1 squared, which comes out positive, times a 2 squared, which is a 4. Oh, look, there's my positive 4. If I plug in n as 3, I would get a negative sign out, and I would get a 9 because it's 3 squared. Oh, hey, there's my negative 9. If I plug in n as 4, I'd get a positive out. The negative 1 to the 4th would be positive, and I'd get a 4 squared. Oh, look, there's my 16. And lastly, if I plug in a 5, I would get a negative because it would be a negative to an odd power, and times a 25. So there's my answer. So again, a lot of this is just spotting the patterns, right? And then making a hypothesis of what the answer is going to be based on that. So my answers in those two look like this. Now in the last one, the biggest thing to recognize here is that my denominator is that my original value again starts at n as 1, and my denominator is a 2. Now again, we saw up here that there are two ways to logically get from a 1 to a 2. It might mean that you're adding 1, it might mean that you're doubling. Well, up here, I was doubling n, and we could see that. We could see that 2 times n gives me a 2, 2 times the 2 would give me a 4, 2 times the 3 would give me a 6, and so on. Down here, it seems to be the opposite case. It seems that this 2 might be n plus 1, right? So, and sure enough, when my n is 2, the bottom is 2 plus 1. When my n is 3, the bottom is 3 plus 1. And when my n is 4, my bottom is 4 plus 1, which is the 5. So it seems that my hypothesis is that a sub n is a 1 on top of n plus 1. And that turns out to work if you check it. So again, some of these are going to be easier. Some of you are going to spot this very quickly, but this is mostly about pattern recognition. Look at the pattern and think, what things could I do to figure out this pattern?